Okay, section 5.1, number 23, and this was a swimming pool, and we wanted to find volume. Okay, the volume of water in a swimming pool, a rectangular swimming pool, is 30 feet wide and 50 feet long. The table below, you have a table that gives you the depth of H of the water at 5-foot intervals from one end of the pool to the other. Okay. Alrighty. Okay, the table below shows the depth. All right, estimate the volume of the water in the pool, A using left endpoint values, and B using the right endpoint values. So let's take a look at this one. So we'd like to take a look at this. I kind of drew a little sketch. So this is your pool, and you can see kind of it's getting deeper and deeper, so it's kind of hard to see. But this is at the very edge, and the very end, and that's a 0, and that's when it's 6 feet deep. Then it goes to 8.2 feet deep, and then 9.1 feet deep, etc. 9.9 feet, so it gets deeper and deeper. Okay, so this is the width of the pool is 30 feet, and the total length is 50. But we're dividing that up into little slices, all right, or sections that are 5 feet by 5, 5, 5. Okay, so we have these little blocks, which are just, prisms, and the area of a box is length times width times height. Well, the width is always 30. The lengths of each of these little ones are going to be just by 5s, and the heights are given by the table. All right? Or the depth of the water, basically, which would be the height of these little boxes, of these cylinders, or these, not cylinders, these little prisms. These rectangular prisms are boxes. So those heights are all given by the depth of the water. And so each one, this would be the first block would be 30 by 5 by 6. And the next one would be 30 again by 5, and that would be by 8.2. So we could factor out the 30 and the 5, and this would give me all of my left endpoints. So I use the table, that's 6. So this would be 0 to 5, so that's the first interval. So that's the left endpoint, all the way up to here. And I don't have a right endpoint. I'm not using the far right. So those would be my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. All the different depths of the water. So I could add all these up, and I added all these up, and I got 103.1, and I multiply that by the 150. 30 times 5 is 150. And each of these would be feet, feet, and feet. So I would end up with 15,465 cubic feet. And then if we use the right endpoints, then basically the same setup, except instead of starting at 6, I'm starting at 8.2. Those are the intervals. Again, I'm using the right endpoints of all these different little blocks to get the volume. And I add all these up, and I end up with 110.1. And I'm using the far right now and not the far left because I'm using RRAM. And I add all those up and I end up with 110.1 times 150, and that was 16,515 cubic feet. So that was number 23. And let's take a look at number 24. And this is the nose cone, and we're going to approximate that. So let's just take a quick look at this first. Let's take a look at it. So this is our nose cone. And we're going to use these cylinders to estimate the volume of this nose cone. So we're going to use 5 cylinders, although if we're going to use the left endpoint, you can see how the radius of this first cylinder will be 0. And this would be the radius of the second, third, fourth, and fifth. And I'm not going to use the right endpoint, which would be 5. That would be an overestimate. This is going to be an underestimate. So we're going to actually end up with just basically 4 cylinders to estimate this. Now the height of each of these cylinders will be 1, because I'm dividing my interval into 5, 0, 5 into 5 subintervals. Okay? And the radiuses of each of these cylinders will be given by this equation, the square root of x. Okay, so take a look at that sketch, and let's take a look at what we did on this. And here we have it. So remember, the volume of each of those cylinders is base area times height, or pi r squared h. And again, this is my interval 0 to 5. I've got, that represents 5 subregions. Each of those would be of length 1, which actually represents the height of each of those cylinders. So height, which is delta x, which is 1, and my radius is going to be given by square root of x. But remember, the volume is pi h r squared, so I've got pi h r1, pi h r2, pi h r3, pi h r4, pi h r5. That would give me the volume of the 5 cylinders, so I just factored out the pi and the h being 1, and then each of these would be the radius squared. So using the left endpoint, it's going to be 0, the square root of 0 squared, the square root of 1 squared, the square root of 2 squared, the square root of 3 squared, the square root of 4 squared. But that's nice because that just can't, the squaring from the formula cancels out the square root that's in the equation of the curve. So we just end up with pi times 1, 0 plus 1 plus 2 plus 3 plus 4. That's just 10 pi. Pi is 3.14159, so it's just 31.4159. 3.14159, and then just move the decimal point one place, and you get 31.4159. So didn't even need a calculator for that one. Okay? So I hope that helps.